Hi there, this is another look at partial fractions, the final stage of partial fractions, if you like, for as far as we're concerned with A Level Maths. And it's looking at a particular type of partial fractions, which are called partial fractions with repeated linear factors. So repeated linear factors here. And if you like, the reason why they're called repeated linear factors is because it says x plus 1 squared on the bottom. And it's usually for A Level Maths a square term. And so I've got an example here. Ignore the top, doesn't really matter here so much. But you notice I'm trying to do these partial fractions, and it says just a boring one. We'd describe this as a normal linear factor, 2x plus 5 or something like that. And that gets a really, typical ones that we've seen before. You chuck that on the bottom of a fraction, you write a on the top. That's okay. It's this bit which is called a repeated linear factor. And the fact that it's repeated causes it to appear twice over here. Both of them get a letter put on top, B and then a C. But you'll notice one says Rx plus S, and the other one says Rx plus S squared. This is what we're doing today. So let's have a look at a little starter just to remind you of why we're trying to do this. This is adding together some fractions, subtracting fractions as well. And you should recall that on these you tend to put them all over a common denominator. And because nothing goes into all three of them, you kind of end up having to write all three of them on the bottom, which is easy enough. So the x minus 2 has gained these two on the bottom, so it's 3 lots of x plus 1. X plus 2. The x plus 1 has gained the other two, so it's minus 2 lots of x minus 2, x plus 2. And the last one, the x plus 2, has gained these two, so it's minus 1 lot of x minus 2, x plus 1. So then we just multiply out the brackets, and I get 3 lots of x squared plus 3x plus 2. Minus 2 lots of x squared. Alright, when I do that, it's the difference of 2 squares, so it's x squared minus 4. And the x's cancel, minus, and what do I get here? It's x squared minus x minus 2. I think that's right. All over that triple bracket, which I'm too lazy to write. And then if I tidy this up, well, I get 3x squared minus 2x squared minus an x. I reckon there's no x squared left, actually. Then I get 9x. There's no x's here, plus another x, I get 10x. And then the numbers, I get 6 plus 8, because minus or minus, that's 14. Another plus 2, I reckon plus 16. Over, now I better write this on my final answer line. You do the same, I hope. There you go. So that's what I reckon the answer is. I'll check that in a bit. Now, this one is the real reason for doing this example now, making you add fractions together, which of course we've seen lots of times, even at GCSE. But the reason for doing it is because I've got x plus 3 and x plus 3 squared. Hey, look, this is my repeated factor. It's repeated because it's got a squared term. It's like x plus 3 times x plus 3. So the point being, because x plus 3 goes into this, I don't need to multiply them all together. I can just put it all over x plus 3 squared. And what that means is this one was over x plus 3 and it's now over x plus 3 squared, so it needs a 1 times by the x plus 3. Whereas this one's actually not being times by anything at all, it's just what it was, so it's just plus that and leave it alone. So what's that give me? That gives me x plus 4, I reckon, over that repeated factor. I'll just check that I've got them right. 10x plus 16 over those triple, and this one's x plus 4. Yeah, so the question's right. The question really, I suppose, is what is the significance of this? And the significance is, for what we are going to do, we are working backwards from here up to there. So we will be given an expression like this, and we'll be asked to write it in its partial fractions. This is what we mean by partial fractions. They've been parted, if you like. They've been put into parts. And what you'll notice is when I've got an x plus 3 squared, I have to take account of the possibility that they appear in two different places. So bear that in mind when we come to our first question. All right. So my first question, it says 3x plus 5 over that. And when I do this, I am going to show you how to write it. and we write it with an a over the x plus 1 squared plus a b. It doesn't really matter which order you put these fractions in as long as you've got them all. Notice x plus 1 squared, but then I have the x plus 1, a bit like our example in the starter, plus c over the other one, and that other one is just over x plus 2. There's no squared involved, so it's just 1 like that. If I was to now multiply all this out, you remember doing this last time, you would get, in fact I'll just do it here, I get, now I want to put this over, remember, the same as this over here. And so even though I've got 3 fractions here, I'm only going to have 2 things on the bottom. And that's because the x plus 1 and the x plus 1 squared both go into this term. So what have I done to the a? Well, the bottom's been times just by the x plus 2. So I got a lots of x plus 2. What have I done to the b? Well, the b is a bit more complicated. It's been times by one of those and one of those. So, because it was an x plus 1, now it's an x plus 1 squared. And plus the c has gained that bracket with a squared on the end of it. So the reason for doing this really is, once you're good at that, that's over that double bracket, I've got squared there, it allows me to ignore the bottoms, a bit like we were doing last time, and I end up with this statement. And this is where I want us to get to, really, that we can jump straight to that line without having to do the line in between. I've only shown you it really so that you know what I've done. So let's pick a number. I'm going to pick x equals minus 2. And if x is minus 2, that will disappear. And this will disappear as well. That's a great thing about it. And this one won't though. So the left-hand side, if I put minus 2 in that, I reckon I'll get minus 1. And that is equal. That should be equivalent to. But here it's equal. That disappears, that disappears. Minus 2 in here gives minus 2 plus 1, which is minus 1. Square root is 1, c. c equals minus 1. So that one's done. I can do the other one, x equals, well, if x equals minus 1, because that will make that one disappear. Now, it'll make this one disappear, make this one disappear. The only one that will be left is this one here. So minus 1 in here gives me minus 3, that gives me 2, and that equals minus 1 in there gives me 1a. So I reckon a is 2. Now to get the last one, I've recently seen someone do this slightly different to the way I always used to do it, but I've seen them write x is 0. So if you put x is 0, you write 5 on the left hand side. And of course here things don't disappear quite so easily. I get 2a. A 0 there, that's 1 times by 2, that's 2b. And 0 in there plus c. And of course I know what these things are. So I can write 5 equals, what was a? A was 2, 2a is 4, plus 2b, that's what I'm trying to find. And c was a minus 1. So it's like 3. I reckon 2b equals 2 and b therefore is 1. You should of course rewrite this. So if I was doing this I would hopefully get the same thing. I'd write a over, what was it? 2 over the x plus 1 squared plus b was 1 over the x plus 1, and yours just has to agree with yours. It doesn't have to be in the same order as the answer, of course, and c was minus 1. Now you could write minus 1 there. Some people would write it at the front instead there, which is what I've done. But that looks right, 2, 1 and minus 1. So we'll look at the next question. So we've got here 4x squared minus 3x plus 5 over this one with a repeated factor again, so that's what I want you to get used to, x minus 1 squared x plus 2. So when I write this out, get into the habit of knowing that's going to become a over the first one squared plus b over just the x minus 1 plus of course the c over the x plus 2 because that never had a square term. And I'm going to miss out the middle line. You might need to go back and check why this works. I want you to get into the habit of being able to do this by missing it out. But I'm going to write this as if it was all over this, and the x minus 1 squared of course has gained an x plus 2 if I get it. So it's a lots of the x plus 2. The b is the one that gains a bit of both. minus 1, x plus 2. Whereas this c has gained a double bracket, x minus 1 all squared. Now on that basis, set x equal to minus 2, because that will make the left-hand side, or the each of those brackets disappear. Now if I put minus 2 into there, and minus 2 into there, I get 16, 21, I reckon 27. And that equals, that disappears, the only one left is this one. If I put minus 2 into that, I get minus 3 squared, which is 9, 9c, so c equals 3. Now I go x equals, it says minus 1, so I'll say 1. Put 1 into there, I get 4, plus 9, I reckon 6. And if I put 1 into here, these disappear. The only one left is this one here. So x plus 2, that's 3a. So a equals 2. And the trick that I used last time was to find the last one. You just randomly pick a number. The easiest number to pick is 0. So x equals 0. Into the left-hand side, I get 5. Into the right-hand side, well, you've got a bit more work to do. 0 plus 2 is 2a. 0 here gives me minus 1 times that 2, which is minus 2b. Plus, put 0 into that, I get just c. So I know what a is 2, so that's 4. And minus 2b plus 3 is 7. So that's 7. Move it over, I get minus 2 equals minus 2b. I reckon b is 1. So hopefully when I see the answer, yeah, so I get 2 over the first one plus 1 over the second. And of course you are meant to write it like this, but everything else, alright, the only thing I'd check is this one here. Let me just check, see if I've got it right. Yeah, and I've just checked, that should be a plus there, as I said it should. So last one, and then we'll finish. Now the only difficulty here is you'll notice it's x cubed at the top, and the power, because of this thing here, is x cubed on the bottom as well. So to do this, you've got to do a bit of long division first. This, when I multiply it out, is x squared plus 2x plus 1. And if I times that by x, I get x cubed plus 2x squared plus x. And this, of course, is really what I'm meant to divide into the denominator, because I can't do this unless I have a lower power on the top. And I notice I've got x cubed on the top as well, and I've got to get rid of that. So I'm just going to do a bit of long division. X cubed times that is 1. So 1 times that gives x cubed plus 2x squared plus x. Put it in a bracket to remind me to take away. And that gives me 3x squared plus 7x plus 3. So really, I'm looking at 3x squared plus 7x plus 3 over x plus 1 all squared, x. And I'm going to set this equal to a over x plus 1 squared plus b over x plus 1 plus c over x. And if I tidy this up, I'll get 3x squared plus 7x plus 3 is equivalent to a times by the x plus b lots of x plus 1 and an x plus c lots of x plus 1 squared. I'm going to quickly find out what a, b and c are. So if I say x equals 0 here, and x is 0 is great because it will get rid of that one and that one. So that gives me the left hand side is 3 and 0, that's c. Well, that was easy. If I say x is minus 1, then on the left hand side, I'll just put in my calculator. I get minus 1 equals, and on this side everything disappears apart from I get minus a. So for a equals 1, and I'm going to need to pick another new value. I'm going to pick x is 2, since I've already used the 0. The 2 on the left hand side gives me 29, and that equals a times by x plus b. I'll quickly do this and pause it. And when I quickly did that, I got b equal to 0. So the answer, according to me, is that. Notice the 1 at the front, which comes from here, the rest as we said. And I want you to have a go at exercise 5D. Have a try, and we'll talk about this in due course.